In lesson 9.6.5, we're going to write an equation of a line in slope-intercept form given the slope and 1 or 2 points. Directly below this video, there's going to be another video because in the second video, I'm going to show you how to use the point-slope formula, and some of you may prefer to use that method. I'm going to show you how you can use the slope-intercept form of the equation to solve these type of problems, and then the second video will be all the same examples, but they're going to be showing you how to use the point-slope form of a line. So step 2, we're going to then write the equation in slope-intercept form. So when we do this, we can start with y equals mx plus b. All right, since we know m and we know one of the points, we can substitute this in. So y is 1 equals m is 3 and x is 2 plus b. Okay, when we think about an equation, if we know only, or if we only have one variable, then that means there's one solution. We just need to solve for that variable to get our answer. So what we have here is 1 equals 6 plus b. We subtract 6 on both sides. So we have b is equal to -5. Now that we know what m is, okay, m equals 3, and we got that from up here, we can write the slope-intercept form. So we have y equals 3x minus 5. So now where do we get this from? Okay, well we have the y and the x. Those are our two input and output, our domain here x and our range y. We use the numbers 2 and 1 to plug into our formula to solve for b. But now that we know b is -5, we're going to go ahead and put it back into y equals mx plus b form. We know m is 3, slope is 3, and we know that b is -5, so we have -5. So now if I were to put this number in here, I would get 1 out. So 3 times 2 is 6, 6 minus 5 is 1. So any point on that line is going to go ahead and fit as a solution into that function. So y equals mx plus b. Okay, so we have y is 5, m is 3, x is -2, and we have b. So since there's just one variable, we can solve for it. So we have 5 equals -6 plus b. Then we need to add 6 on both sides. So that way b is equal to 11. So now we can say that y equals 3x plus 11. The slope is 3, that's where I'm getting this from, and b is 11. So this is my answer right there. Slope-intercept form of the equation that goes through this point using that slope. Y equals mx plus b. Okay, y is -7, so I'm going to have -7 equals -1. I can put that in parentheses, times x, which is 4, plus b. All right, there's only one variable, so that means there's only one solution we need to solve. -7 equals -4 plus b. We add 4 to both sides to get b is equal to -3. So we're going to have y equals -x minus 3. Okay, the slope is -1, so I could write -1x or just plain -x. The b is -3, so I put -3. So that's my answer. Alright, so then when I'm given 2 points, we can find the slope of the line containing the given points using the slope formula. And then we're going to use the slope and either of the 2 points to find the y-intercept. Again, you can do that 2 ways. You can do the y minus y1 equals m times x minus x1, and that's shown in the second video. Okay, so if you're looking for another way to do this, watch the second video and they'll show this way. Otherwise, we'll just do the y equals mx plus b form and solve for b and then put it back into slope-intercept form. All right, so the first thing we need to do, and I'd like everyone to do this when they're doing homework, is write the equation y2 minus y1 over x2 minus x1. Okay, and then this is going to be my point 2, and this is my point 1. So you're going to want to write those points for your homework. But since it's here for us, just like on a worksheet or something like that, you can just label it as 2 and 1. Then let's substitute this in. So y2 is 1 minus y1 is 4 all over x2 is 3 minus x1 is 2. So I'm going to have negative 3 over 1, which is negative 3. So this is my m. So if I said m equals all of that. So this is my slope right here. Okay, so now we're going to say y equals mx plus b, because this is a format we'd like to get it into. Since I know two of my points, you know what, I'm just going to go ahead and say that I'm going to use point 2. So y is 1. So I'm going to say 1 equals negative 3, and I'm getting that because that's what I found my m to be. X is 3. I can put that in parentheses as well, plus b. So now I'm down to one variable, so I can solve for that one variable. So let's say that 1 equals negative 9 plus b. We add 9 to both sides. So that way b is 10. And now we can rewrite the whole thing in slope-intercept form. So y equals negative 3x plus 10. Okay, now I would like to point out that the other way of doing this, y minus y1 equals m times x minus x1. The other way of doing this sometimes is a little bit easier because you save a little bit of time and there's one less step that you have to do. But if you do prefer doing it this way, this is fine as well. I would like to show you both ways I'm doing it. So feel free to watch the video and see if you prefer maybe that method. When you solve it doing this way, you have it in slope-intercept form right away. So that it's sometimes a little bit easier to do it that way. All right, so we have 2 points, y2 minus y1 over x2 minus x1. You need to write that every time. Again, this is m, so we can write that in front. This one is going to be my point 2, and this one is my point 1. So let's go ahead and write this out. So we're going to do negative 2, which is y2, minus negative 6. So this is an uh-oh. Let's fix that right away. And then x2 is negative 4 minus negative 5. That's an uh-oh, so we can fix that. So then we're going to get 4 over 1, which is 4. So that's my slope right there. So now we have y equals mx plus b. Let's substitute in. I'm going to use 0.2. It doesn't matter which one you use, but that's the one I'm going to use. So negative 2 is my y equals 4, which is my m. X is negative 4. And then we have plus b. So we have negative 2 equals negative 16 plus b. So we got to add 16 to both sides. And we're left with b is equal to 14. And so now we can rewrite it into y equals 4x plus 14. That'd be slope-intercept form, and that would be my final answer right there. So again, there might be a little bit more work to show using this method, but some of you might prefer doing it this way. Otherwise, we do the y minus y1 equals m times x minus x1. And for examples of how to do it that way, be sure to watch the other video. Okay, for our last example for today, we're going to work on this problem here. We want to find a equation that can be used to predict if fares continue to increase at this rate. So they want us to let x represent the number of years since 2000. So this would be x, and over here would be y to represent the airfare. Write an equation of the line that passes through 5,366. That would be this one. Because remember, it says since the year 2000, so this would actually be like 4, and this would be 5, and this would be 6, and 7, and so on. So they want the equation of the line that passes through these 2 points right here. So that's easy enough. We can just go ahead and do y2 minus y1 over x2 minus x1, and that will always be equal to our slope m. So y2 is going to be 378 minus 366 over 6 minus 5. So that's going to give us 12 over 1, which equals 12. So basically $12 per year. Now we can put this back into y equals mx plus b form. We're going to have to solve for that b, though, eventually. Well, let's use 2006 data. So we'll go with 378 equals 12 times 6 plus b. Okay, so where did I get the y value from? 378, that's from right here. And the 12 came from our slope, and the 6 came from the year 2006, and we're still looking for b. So we have 378 equals, if you want to, you can pull up your calculators, and we can do 12 times 6, which that equals 72. Plus b. So now we need to subtract the 72 on both sides to get b is equal to 306. So now we can put this back into slope-intercept form. Y equals 12x plus 306. And that would be an equation that we can use to predict the increase in airfare. Now, sometimes these type of problems say, then find what the airfare would be in 2025. And then we would just be able to plug 25 into this equation and find out what the airfare might be in the year 2025. So that's the end of our examples for this method of doing 9.6.5. Be sure to maybe take a look at the other video that I have posted that shows the y minus y1 equals m times the quantity x minus x1 form. You may prefer doing it that way. As I said, it sometimes saves a step. So be sure to check that out. Also check out the answer key which I posted on Moodle.